Good day. Today, I would like to present to you my transportation, pavement, and geometric design projects. My name is Sbonsani David Kanyile. My student number is 15305783. The lecturer has initiated a project for us to do to design or upgrade an existing road. Okay, my introduction. I've chosen an area in within the city of Tshwane Metropolitan Municipality, which is Acacia, which is a complex of suburbs in the northern part of Pretoria. These suburbs fall under the city of Tshwane, and it was established around 1904. Based on the information received from the city of Tshwane Metropolitans, the R513 road was built in 1980s, and it is clear that it is a regional route and have exceeded its maximum span. Hence, there is a visible cracks in the pavement structure. I've attached the pictures on the actual projects on how the road is damaged. The civil engineering technologist who was approached by the city of Tshwane to produce a design of the mentioned changes and provide also a design report. Okay, let's look at the project's location now. I've also attached the coordinates where it starts and where it ends, and also the changes, which is 20 meters interval. The road category is going to be B, which I've chosen on the TRH4 table 1. Let's look at the design data now. Before you designing a road, you need to acquire a design data. These factors are taken into consideration during the design phase, and we also look at the design data include the terrain mode, the weather condition, the traffic counts. Let's first look at the weather condition. Acacia is a humid climate with a long, hot, rainy summer. The suburbs usually experience the suburb experiences the typical winter of South Africa with cold. The average temperature is 18 degrees Celsius, with an annual average rainfall of 914 millimeters, and is also classified as a moderate region, ranging from 2 to 5 according to the TRH4. Okay, let's look at the estimated current traffic that we have seen on the road. The current ADT for Brett's road section is estimated to be 866 vehicles per day per lane. The above information is obtained from the traffic count that was conducted by the city of Tshwane. Okay, now let's look at the design guidelines and standards used for design. The following guidelines and standards were used, which were geometric design manual, SANRAL, and also geometric design for rural roads, TORH 17. The overview of the adopted geometric design software. We have used the civil design for this road. This software package supports in the building, the information of modeling, BIM, of different civil engineering infrastructures projects. Furthermore, the software helps the organizing project data, create and analyze the surfaces, and create the layout and road corridors. Now let's look at the road reserve requirement. Okay, the road can be defined. Okay, the road can be defined as a wide strip of land required to accommodate the cross-section elements of the road. The road reserve requirement for this road is ranging from 30 to 50 but typically can be taken as 30 meters. This road is classified under class 3 in the rural region. Base and road cross section we're going to look at is basics lane, shoulders, and also side drains. I've also attached my screenshots of the time I was designing the road using the civil design. And these are the following screenshots that I've attached until the road layouts, which I've also attached on the project, and also the generating the vertical alignment of the road, and also the road long section that I've attached also on the project. Okay, now let's look at the pavement structure design. Okay, we used the design standards and guideline used. We used the guidelines for road construction material under TRH 14, 1985, which is the year, and also the structural design of flexible pavement for inter-urban and rural roads, TH4. The last one is SANDRAL, South African Pavement Engineering Design, which is usually used when for design standards, especially dealing with roads and freeways. The sensor line subgrade CBR values were taken at the interval of hundreds meters in both direction, westbound and also eastbound. Now let's look at the design CBR. I've calculated the average, which was 4.5, and also the standard deviations, which is 1,118, and also our overall design CBR was 3.067%. And also the subgrade class which we discovered was 3 design CBR between 3 and also 7. Okay, to continue with also the CBR values for section 2 now. We also have calculated, which was 5.875, and also under section 2 we also calculated the standard deviations, which was 0.599, and design CBR, which was 5.875. And also for subgrade class, we also chosen the design CBR between 3 and 7. It also continues to the CBR section 3, which we also calculated the average of 16.5, and for standard deviation we also received 2.398, and also design CBR for section 3 we also received 16.5, and the overall design CBR was 13.426%. And the last one was the subgrade class 2, which we have chosen between 7 to 15. Now let's look at section 4, which we also have to calculate the average, which was 14.375, and also the standard deviation and CPR, design CPR, and also the subgrade class, which we also find to be 7 to 15. Okay, now let's look at the design CBRs for different subgrades, which I've now attached everything in one table so that I can summarize what I've calculated for each section from section 1 to up to section 4. These are the calculated CBRs, average, standard deviation, or also standard CBR, and also standard or CBR class. Now let's look at the analysis and projection of traffic data. Since we have collected the information that we needed, as I mentioned earlier on this presentation, that we during the collection of information from the city of Tshwane municipality, we found that the vehicle per day per lane was 866. The road category was B. Design period was for 20 years, and growth factor, which was 4%, which equated to 11,303 from TRH4 table 12. The growth rates, which is 4%, also from TRH4 table 10. The ADT in design year was based on ADT based year, and also the ADT 20 years, which equated to 1,898 vehicle per lane per day. Okay, let's continue with also design information, which we also find. We also calculated our E80, which happens to be 9790 912, and the pavement class for this road was ES10, which is 3 to 10 million 8 kilonewton XL per lane. Let's look at the subgrade design. The aim of the subgrade design is to protect and use and improve the bearing capacity of the in-suit subgrade material so that the pavement will fulfill the service objective over the analysis period. The bearing capacity of the subgrade is improved overlaying and an appropriate layer material to achieve the graded structural balance pavement system. I've attached or calculated the subgrade design, the lower selected layer, and also the mentioned upper selected layer, and the last one, which was treatment of in situ subgrade. Now I've also attached the most important aspect of design, which is pavement design alternatives. As you can see on my presentation, on my slide that I've attached it, and also the design alternative selected, which was surfacing, due to the high traffic volume on the road, and asphalt surfacing is only viable option. A continuously graded asphalt with conventional binders of a minimum of thickness, which was 30 meters proposed at this time, and also the base layer that I've mentioned, which we considered the alternative we considered were the following, which was G2 crushed stones, C3 stabilized layer, G2 crushed stones, and compacted to 89% of density was proposed. Now let's look at the pavement alternative selected. The C3 established basement is regarded as a high risk due to the upper parts of the layer that may crash with resultant loss of density and bearing capacity. And also, stabilized material normally cracks as a result of shrinkage and causing premature cracks to appear on the surface of the layer. The cracks will allow the ingress of the water into the pavement layer, with the consequence of rapid fracture of the pavement layers. Looking at the pavement alternative selected, it continues to this slide, which we look at now the sub-base layers of the road, and also we look at how much it is compacted. We from 95 percentage to 96 percent of modified H2, and proposed to ensure that it has enough required support for G2 base layer, and also to accommodate the high volume of water used in the construction of G2 layer. Now let's look at the drainage design. We're going to look at the design standards of drainage and also guideline and manual used. We use the central drainage manual and also since we know that in the road design it's very important to make adequate provision for drainage system. The water can easily damage the road if you don't have the proper drainage system or drainage design system for that particular road. The drainage system is very important in the road structure. Okay, we're gonna look at the requirements of the road drainage system, which is the one that we usually know, which is side drain, should have sufficient capacity and longitudinal slope to carry away all the surface water collected from the roadway. And now let's look at we continue with the road reserve drainage requirements, which is a road drainage system must satisfy two main criteria if it is for it to be effective throughout the design life. It must allow the minimum disturbance of natural drainage pattern. It must also drain the surface and surface water away from the roadway, and also prevent excessive collection of water in unstable areas and also downstream areas. Now let's look at the last one, which we continue with the drainage system design, which is sub-base requirements. Sub-base requirements. Sub-base subsurface requirements. Subsurface drainage is a system removal of excess underground water from the soil. There are general two types of subsurface drainage, which are open and also pipe drains. These open drains, they can receive overland, and also this can be used to surface the drainage. However, open drain are loss of land, and however these open drains are loss of the land, and they can also be suitable for this type of road is also the pipe drain. Okay, now let's look at I've used, as I mentioned, that I've used the civil designer to design the road, the actual road that was prepared, using the student version. And these are my designs, which will be attached to my drawings, which I will not go through them, but I've also the detailed drawing is also being attached on the project itself. Thank you for your time, and I hope everything is clear enough and also understandable. Thank you for your time. Thank you.